Faraday's law of induction is a basic law of electromagnetism, predicting how a magnetic field will interact with an electric circuit to produce an electromotive force. Faraday's law states that the EMF is also given by the rate of change of the magnetic flux, which we can write the equation as below. For one coil of wire, it composed of n identical turns, and its equation will be like below. The Maxwell-Faraday equation states that a time-varying magnetic field always accompanies a spatial varying, also possible time-varying, non-conservative electric field. And the Maxwell-Faraday equation is like below. In this video, we are going to derive the motion EMF equation and how EMF produced with a simple experiment.
Hi, my name is Ahmad Syafiq Surakah bin Syamsuddin. So today I want to explain how to get the equation of the motional EMF. Okay, this is the magnetic coil. So from the magnetic coil we can produce the motional EMF equation. So from the transformer EMF we have from the transformer EMF we have the flux over del T, and then this is equation of transformer. So as you can see, when we push the rod magnet bar to the upward, and then it will produce the magnetic field. So the magnetic field is the upward. So as you can see the negative sign. It is represents the Lenz law. So the Lenz law states that as the magnetic field increase, the B induced will oppose to the magnetic field, which means that when the magnetic field is increased, the B induced is going to downward. So this is according to the law of Lenz law. So from this equation we can expand to get the motional EMF equation. Applied from the magnetic force, dF equals to J dV cross B. As we know, J is rho V U dV cross B, and then rho V dV is dQ, and then you get U cross B. So from this formula we get dF over dQ equals to U cross B, and it also is equal to the EM. EM is the motional electric field. Okay, so after that, by applying the voltage formula, so we assume V equals to EMF, and then automatic E equals to EM, which is motional electric field in the air. So as we know, EM is equal to U cross B. So this is the finally equation of the motional EMF, and this is also the third equation of motional EMF.
My name is Abdul Hafiz, and I will explain about simple experiment of motional EMF. In this simple experiment of motional EMF, there are 3 different coils with each of them have different number of coils. First is single loop coil, second is 10 loop coil, and the third is 100 loop coil. With the first one, the single loop coil tested, there's only a small deflection of galvanometer's pointer happen when the magnet bar moves towards the single coil loop. In the second coil, the 10 loop coil, when the magnet bar moves towards the coil, the pointer on the emitter shows more deflection occurred than the single coil loop. And when the magnet bar moves away from the coil, the pointer in emitter moves to the left and then go back to its original place. The last coil that contains 100 loop of coil, when the magnet bar moves towards it, the deflections are getting much bigger. When the magnet bar moves towards it, the deflection to the right are much more obvious than the previous number of coil. And when the magnet bar moves away from the coil, the pointer moves to the left at much bigger rate. Okay, that's all from me.